Hello. Hi, everyone. Welcome to this new edition of PHP Sussex. Thank you all for coming. My name is Yannick, and if this is your first time at PHP Sussex, we are a Brighton-based user group dedicated to the PHP programming language and to web development in general. We gather once a month, usually on the second Wednesday of the month. In a minute, tonight's speaker is going to join us online. His name is Elie Busanga, and he's going to be patching in from Nairobi to tell us everything about the OWASP 10, which is a list of critical security risks for web applications. And so basically, he's going to show us how to mitigate those risks in our PHP applications. Elie is a software engineer, and he is also a chapter lead at DevSecCon, which is a community focused on security in all stages of software development. But he's going to tell us a bit more about this in a short moment. Also, just so you know, tonight there won't be a Q&A session after the talk, but Elie is going to share his contact details should you wish to, reach out later and ask questions. Before we do any of these, though, first a quick reminder that this event is being recorded. So if you do not want to be filmed or photographed, please do let us know. And then before we get started, Cameron is going to tell us a few words about Runway East, where we are tonight, and Silicon Brighton, who both kindly support this meetup tonight. Over to you, Cameron. Yeah, sure.
Arrow down. Yes. Oh, lovely. Which way do you turn it up, though? Let's see which way this goes. Oh, that's the wrong one. And hello, welcome to Runway East, guys. My name is Cameron, and I work for Silicon Brighton, the hosts of Brighton and Host Tech Sector. I think you've all been to a few other meetup groups before, so you're all familiar with this introduction period. But for those that don't, Silicon Brighton are a company that has 30 or more meetup groups that we all look after. We help out with the project management behind their events, as well as getting them all in the right place at the right time and setting up all of the live streaming equipment so that we can go straight to YouTube. It's free to join, available to people at all levels. So if any of you would like to join either online or in the room with us, there's a lot of ways that you'll be able to help out. And here's some of our supporters that help us out financially. They're a great group of people, along with our sponsors who assist us massively. And if you guys would like to help out at all, we're looking for new sponsors, speakers, subscribers, supporters, volunteers. And what it doesn't say on here is actually meetup group organizers like Yannick, who does a fantastic job at pulling in great speakers and putting on great events with us as well. There you go. If here are our values, we like to honor all of these. And if you see that we're not upholding these values in any type of the events that we're doing, come and chat to us if you feel comfortable, and we'll make sure that that is rectified immediately. Follow us on our socials. We're on the usual suspects. And here are some of our upcoming events, which I'll just pause on quickly. We've got Brighton Pie, which I believe is tomorrow, Green Software Brighton next week, along with People Planet Pint and JavaScript Brighton. If you'd like to join us on our Slack community, the QR code is just there, but I assume that most of you are already on a Slack community, but I'll leave that up for the viewers at home. And scan the code to stay up to date with all of our activities. I believe that is now back to Yannick. So thank you very much, mate.
Thanks, Cameron. Elie, can you hear me, mate?
Yep, I can hear you very well.
And I can see you. How you doing? You right?
Fantastic. How you doing?
Yeah, I'm very good. Thank you very much. First of all, thank you for doing this, for taking the time to talk to us. We really, really appreciate it. And then, so when you submitted your talk proposal, and I realized you were from Kenya, I got a big surprise, right? Because I wasn't really expecting, somebody from so far away to find us somehow. Actually, how did that happen? Actually, so did you stumble upon us on like Meetup or like how did you find us?
Yeah, sure, absolutely. So I was just browsing Meetup, and that's where Meetup did its great job of suggesting PHP Sussex. From there, I went on and learned more about PHP Sussex, about Breton, and of course, I checked out all the links. And yeah, that's how I found out PHP Sussex.
That's pretty cool. And
Actually, thereafter, I remember there was an event that was on the line coming next, so I was happy. Maybe Meetup suggested the event because it was just coming like in 2 days. So I marked my calendar for that, and that was my first event to watch. I don't remember which one was the title though, but yeah, that
that's
was
pretty
how
cool.
I found it.
I find it really cool that you then got in touch to actually submit a talk, and I think it's really great. It also got me curious about like the state of PHP in Kenya. Like, is there like is it a popular language over there? Like, is there like a big community? Like, do you have like meetups, conferences, maybe? Yeah, what's like the state of the PHP community over there?
Yeah, absolutely. Actually, PHP is a widely used language in Kenya, and not only in Kenya, let me say, in the whole countries in East Africa, in the East of Africa. Because at the moment I'm in Kigali, and still Kigali is in Rwanda, and PHP as well is more it's widely used. It's a widely used language. So in my experience in all East African countries, PHP is really widely used. And speaking of Kenya as well, there are a lot of communities, especially around Laravel and Symfony. There are big community and events happening there on PHP. Yeah.
That's great to hear. So PHP is not dead then.
Well, it will never be dead. It's resurrects every year. Let me say it that way.
But actually, are you a PHP developer yourself?
Absolutely, I am.
Very nice. And you are also a chapter lead at DevSecCon, like I was saying earlier, so like the community. I've got to be honest, I had to look up chapter lead because I had never heard of this job title before. So would you maybe like to tell us a few words about DevSecCon and maybe about what you do as a chapter lead for them?
Sure. So literally, actually, DevSecCon is a community around DevSecOps, just as you mentioned it in the introduction. And there is actually an interesting event happening, DevSecCon 24, which started yesterday. So if nobody knew about it, I would just advise you go check devsecon.com and you'll find the event there. There are great talks about AI and application security happening. And one of the chapters is actually the Kenyan chapter, which I lead. And what we do basically is just meeting, organizing event, educational events where we host speakers and yeah, the whole community related event, of course, around DevSecOps.
Makes sense, yeah.
Yeah, we don't focus on, we are not language, it's not a language specific community. It's anything DevSecOps, be it in PHP, JavaScript, whichever language.
Yeah, I suppose that those are principles which can be applied to any language, right? And should be applied to any language, I assume.
Yeah, absolutely.
Yeah. Well, Elie, thank you very much for telling us a little bit more about yourself. But yeah, I'm going to let you get on with your talk now. So yeah, without any further ado, please welcome Elie for his talk, Why Should Software Developer Care About Security?
Thank you. All right. Good evening, good morning for those watching live and those in Silicon Brighton right now. Thank you so much for joining the talk today. I'm super happy and excited to know you are there. Though I can see you. So I'm Elie. I'm known by Elijah. So I'm a software engineer and chapter leader. And there are my socials where I can be found after the talks for any questions. As well, on the bottom, there is the link to the GitHub repository. It's not yet there available now, but after the talk, it will be. So the little demonstration that we're going to do today, they can be found there, of course. So we are here to talk about software security. Actually, let's have a little peek of how is security applied. So if you look around us, we'll find out that security is actually applied in our daily life. You will never board on a bus knowing that the bus has a flat tire. Or worse, board on a plane knowing that there is some malfunctioning in the engine. So literally around us, everything, we have to make sure that we are safe. We are in a safe zone, a safe space. And the same applies to software. The same way, we cannot board on a bus knowing that it has a problem, because literally you will be this guy here who will you will be the passenger mechanic, and you don't want that to happen. So imagine now this is your software that you are developing, and then your user is the one debugging your software in your place, literally, well, when it has security issues in our case. So we don't want that to happen. So we found that security is actually a concept that applies in our daily lives. In everything we do, we can find security. We can see a chemist in his lab, they are wearing gloves. Why? To protect themselves from any chemical reactions. We can see a cook in his kitchen. Whenever he's chopping his stuff there, he has to make sure that he's secure. So security is all over in our daily lives. We actually apply security. Knowing it or not, we do. So now in software development, when you talk about security, there are some terms that attract our attention. Sometimes we hear about attacks. Some other time we hear about vulnerabilities, confidentiality, and all these terms work together to make sure that our development is secure. For instance, attacks, we may hear attacks from third-party people, from third-party packages, from, those guys behind the wall trying to hit on you. You may hear about vulnerability in dependencies that we daily use and download from the internet. And of course, confidentiality first. So there are multiple terms around software security. And as the definition states, which actually is found on the link provided there, where they say software security refers to the process and practices that involved in developing secure software systems. Software that are, let me say, free from those attacks or vulnerability free, where we can say, okay, there is a bit of integrity in this tool. And I'm sure that whatever I'm going to do on this platform is confidential, because we all want privacy. So all these terms, and then there are all other terms that apply around this term security. So it's kind of, it's a long discussion, literally. But then, as we just saw the example previously of these users, of these people here who were trying to board on a plane. Well, these are us. We consider themselves as these people who are trying to board on a bus, right? But I don't think that there is one of us who, before they board on the bus, they try to ask the driver, do you have your driver license? Or are you sure that your engine is functioning well? Well, we don't. And the same applies to the softwares that we built, because there is no user who, before using your tool, okay, let me say, most of users will just trust you to build something that is reliable, that they can depend on, that they can do what they want to do. Not that they are stupid to use your tool, but because they trust your expertise to be a good, knowledgeable software engineer to develop a secure system. So thanks to the people at OWASP.org, we can have this report. It's one of their projects. This is of 2021, where they try to give us a top 10 list of most security issues that were found. We can see we have broken access control, we have cryptographic failures, injection, insecure design, security misconfiguration, and all these, the list is long. And there are very interesting, actually, topics to discuss. However, we cannot go through all of them. We're gonna just pick some of them. And for today, only the first three. and to see how we can protect ourselves from these. So let's start with broken access control. Literally, there are multiple ways we can, of course, prevent or be safe from this attack by making sure that we deny access to, they say, all resources and only allowing access to the one that are supposed to be public. By doing this, we actually reduce the risk of being attacked. We can also ensure that action on resources are only limited to the correct users, basically applying concepts like policies, roles, and permissions, middlewares on request, and all this can work to make sure that we are safe from this attack. And to my WordPress friend, I think we are all aware of this point 3 here, because literally that is the number one thing for a WordPress developer to do, to make sure that I'm safe, my directories are safe, and the user can just access anyhow my files the way they want. And it's just by creating an index.php file and leaving it empty, or just telling the user some funny stuff there. So we can prevent it in many, many, many ways. And then we have injection as well. Of course, there are multiple ways we can prevent this as well, with the use of ORMs. Like today in 2024, we have a couple of them, and the most used ones is Eloquence in the Laravel world. You have Doctrine, which is used in the Symfony world, and I know there might be many, many others. And to my friends writing SQL themselves, we know that we don't want to hard code the value when writing our queries, but we want to use prepare. We want to use prepare statement to make sure that we are safe from any injection. And of course, the best rule of all, never trust user data. You have to validate, sanitize user provided inputs. And now here we have a very interesting one. Okay, this one is broken here, but we're just gonna proceed like that. But basically, we're gonna talk about cryptographic failure. And here we're gonna try to go a little bit in deeper into this, because we're gonna talk about protecting stored data and data that is in transit. Here we're speaking about the internet, and the internet is open to everybody. So we're gonna try to have an example here where, so just allow me to do this, please. Yeah. Okay, so that's better. So we're gonna have a consumer and a producer. Well, yes, we have a milk producer. It's considered as a certain service that produces milk. And you have a milk consumer, which is a certain service that consumes milk. And then the consumer will request from milk from the producer. But then before the producer give or produces milk for the consumer to consume, the producer needs an access key. So we're going to try to see how we can implement this communication and making sure that we are trying to secure this communication to the best we can. We're going to do some demonstration in the code. Okay. So just a quick walk through the state of the code of the demo at the moment. So I have this directory here, consumer, and I have this other one, producer. Basically, these are just two PHP service. There is no framework used, just some quickly generated file. And then the producer actually has a controller that produces milk. And then it's exposed through a certain API endpoint, produce milk. So if we go to test it in our client, and we say, okay, producer produce us milk, he will literally just give us milk. Cool. So the consumer, what is gonna do? The consumer is exposed now to the user. So the producer is behind. The user doesn't know about the producer, but the user at least knows about the consumer service. So the user will be able to access the consumer service through a certain API endpoint called request milk. And via this endpoint, the consumer service will communicate to the producer, fetches the milk, and then return the milk to the requesting user. So if we demonstrate that as well in our API client, we have the request milk API endpoint. And right now, it's just requesting milk because we have not yet hooked the two. Good. So if you're wondering how this is happening, I have the router, a router file here, which is doing everything behind the scenes, parsing the route, the request body, and routing to the controller, of course, and then return the milk. This is for the producer. The same to the controller of the consumer. So there is the route handler there, which handles the route and then forward them to the controller, and he just requests the milk for now. So, okay, now let's have the two work together. So what you're gonna do, you're gonna use Gazo client to make that call between the two servers. So I'm gonna say over here, okay, since the consumer, the producer, is giving me a post API endpoint, cool. So okay, just so you know, I have Gazo already added in composer.json, so it's not coming from nowhere, so it's already there. So what I'm gonna say, I'm just gonna have my client here, and this will be a new Gazo client. All right, and then I'm going to request for the milk. I'm going to tell my producer to produce the milk, which is available on this endpoint here. It's all done. Produce milk. All right. Cool. And then, of course, this will give me response. And instead of doing that, let's just echo the response body. Good. So now we're going to go back to our API client. And instead of accessing the producer through its endpoints, let's access the producer through the consumer. And cool, we have the response returned. Now the producer is able to pass the milk to the consumer and have it returned to the user. But then our communication is open. Our API endpoint is open to anyone to use, which is not safe. So let's try to go a little step further and secure this endpoint. I'm gonna go back to PHP Storm, and let's say the producer say, before I produce any milk, I need you to provide an access key. So the producer is going to issue an access key, going to give the consumer a key that the consumer is going to use whenever he wants to fetch any milk from him. All right. And the key, of course, it's going to come from the request body. All right. So we're going to say access key equals request body. Remember, we already have the request body passed from our router, deals with everything. Access key, which is part of the request. So okay. And then we're gonna check if we have an access key. Then we're gonna proceed, or if not, we will just tell the user that the consumer that they are not allowed to fetch any milk from us. So let's just echo not allowed here, and then return. Okay, that's the request body. So I'm going to come here, and then I will need to provide as well as JSON format. I'm going to provide the access key, which for now, let's just give it the random name, access key. All right, this key should, of course, come from the producer, because the producer is the one to issue this key to the consumer. Okay, let's just check there. Okay. They're not allowed, else we produce the milk. So if you go back to the API client and try to fetch the milk, now we have the milk. But if we try to change to the consumer and pass something else here, cool, we are not allowed to fetch any milk. Great. So, but we don't want to pass the access key in this plain format. We want to pass the access key in a way that's only private for the consumer and the producer, because this is the internet. And one of the ways, there are of course multiple ways we can secure this, but one of the ways we can do this is through the HMAC encryption. I'm gonna bring it over here. With this actually way of hashing keys, we ensure that no one except the producer and the consumer can know what the value is. And it can't be first decrypted, because only the consumer and the consumer and the producer, they know, they have a contract that they have signed on how they want to encrypt this value. So in contrary to other hashing or encryption ways, this hashing has to be made on both sides, the client, on both the consumer and the producer. And then the two values have to be checked if they are equal to have the permission passed. So it's not like we would encrypt the value and then decrypt it on the other hand. But in this way, when we use actually the HMAC encryption algorithm, here we are encrypting on both ends. So basically, the producer is going to encrypt the access key with its algorithm and access key and secret key, of course. And then the consumer as well have to know the way the producer encrypted the value. If the consumer tries to guess the way the producer encrypted the value, it will fail because the comparison will fail. So the producer has to tell the consumer, you have to hash the access key in the same algorithm as the same as I hashed it, with the same secret key, hash, of course, and then we hash the same message, which is the access key. So we find this like another layer of security, because there is no way, first, the secret key can be guessed unless one of them exposed it. And no matter the iteration, it cannot be decrypted. There is no decryption with HMAC. So let's try. It can be, you can find more details on this link by Okta. It provides more description on why it's one of the good ways to encrypt data, especially most sensitive data when shared across the internet. So let's try then to sit in practice. So let's say the consumer says, okay, I'm gonna have, let's create a class here, and let's call it access key service class. Good. And then in this class, the producer is going to expose two functions. One is generate access key. And we're also gonna have another one, which is to validate the access key. Sorry. Because when validating, we're gonna accept an incoming one. And we're gonna check if the generated access key equals the incoming access key. This is the one coming from the consumer, of course. So when we are generating the access key, of course, we know we have the access key, which is as of now, it's just a plain text access key. Of course, this should be something stored in a certain OceanDB cloud database, something safe. Cool. So what we're gonna then return here, we're gonna use the HMAC hash function by PHP. We're gonna specify the algorithm we wanna hash it with. We're gonna specify the message we want to hash, of course, is the access key. And then we need a secret key. And this secret key should as well be shared with the consumer. Because the consumer on its end will also use the same secret key to hash and then send the access key. So of course, this as well should be stored in something, in something solid, certain database. But then we're gonna have it here just for sake of the demo, and then we just pass the access secret over there. Cool. Now in our controller, we're gonna say if service, then we're gonna pass the validate access key. Of course, which will be the incoming one from the consumer. And then this should return a Boolean since it's a string to string comparison, of course. So if it fails, then we don't allow the access. If it succeeds, then we proceed and we produce the milk. Cool. So let's go to the consumer then and try to pass the access key as plain and test with our client. If you request the milk, we have our class key service, of course, because we need to import it. Just import it over there. And we have the access is not allowed. So what you're gonna do, I'm gonna go to the consumer, the controller, and we're going to use the same hashing mechanism to hash the same access key with the same secret key and then pass it to the request. So on top here, we're gonna have our access key, which is the access key, and secret key, which we give the value of access secret. And then we're gonna hash it as well. It should be the same algorithm, and our message is the access key, and we pass the same secret. Good. Let's call it hash key. And then over here, we're just going to provide our hashed key. Let's go back to API client and send a request, and boom, we are able to fetch the milk from the producer and return them to the client. That's good. So by doing this, we kind of ensure that the communication from the consumer to the producer is safe, and only the consumers who are allowed will have to request the milk from the producer, and not anyone else. Perfect. So this is about the cryptographic failures, because cryptographic failures, these failures mostly happen when we use maybe outdated cryptographic functions, like we know about the MD5, which is no longer recommended to be used, and any other not safe algorithm, maybe that can be easily decrypted, and we use them in our code. But at least when you know that we use a secure one, like HMAC hashing, we are safe that only the clients who are supposed to connect with the server, with the producer, are able to do that, because there is no way they will ever know the value of the secret. No matter what decryption, no matter how interception they can do, it will be hard for them, not to say impossible. So the last one that we're going to look at then is the vulnerability in outdated components. So we are software developers, and we don't reinvent the wheel most of the time. We use tools that exist already in the ecosystem. We use dependencies that people have built already. And most of the time, we don't check them. However, we have tools that are available for us to use that can help us be at least aware of some issues that may occur and some of dependencies that we may use in our project. And some of them are Snyk, JFrog, and SonarQube. With these tools, we can be able to integrate them in our development pipeline, even our deployment pipeline. And whenever we are developing, they even have actually more advanced checking, where they can provide suggestion where they think our logics may not be as safe as they should be. So they will read our code, they will scan our code, and even suggest us security measures that we can implement. They can as well scan our dependency trees and tell which dependency can have a certain vulnerability in them. You can check them out, of course. They are all, some of them, they offer free tier plans, especially Snyk is one of them that I use, and it does a really good job. Cool. So that's all actually for today, and I hope you learned something. And thank you so much for joining. There are my socials where you can find me on LinkedIn. Again, GitHub, where the code will be uploaded right after the talk. And if you have any question, of course, feel free to reach out. Thank you so much.
very much, Elie. Yeah, thanks, mate. Super nice talk. I'm always impressed by the people who do some live coding during their presentations. So yeah, very well done. And also, I just want to say, like, on that last point about outdated dependencies and stuff, Peter Falk's talk that he did for PHP Sussex in July is all about like Composer and how to update your components and stuff like that. So it's a very nice complement then to what Elie just talked about. And it's all available on your on our YouTube channel already. Elie, thank you very much. So yeah, then again, if you want to ask Elie some questions, like yeah, take notes of the contact details and get in touch. But yeah, I'm gonna free you now. So yeah, thanks again for talking to us tonight. We really appreciate it. And yeah, hope we can do that again sometime soon.
Thank you so much, Yannick, for having me, and thanks to everybody for joining.
It was a pleasure, mate. Take care.
Yes, take care.
We can wrap this up. I don't think I've got many more things to tell you anyway. So yeah, thank you all for coming. You're welcome to stay for a bit longer. There are some drinks left and probably a couple of slices of pizza. And yeah, but yeah, thank you for coming and hope to see you next time. Take care.
Oh, good.